This video is entitled Normalization Example Customer Favorites and goes along with the Normalization chapter, Chapter 11 of Introduction to Database Systems Modeling and Administration. It's suggested that you watch the normalization video first to be comfortable with the terms as I go through this normalization of an example. In this example, your client gave you a spreadsheet. Now I've only given you four of the detailed rows because I didn't want to bury you in the data. This spreadsheet is a mess. The first column contains a customer number. The second column contains a customer's name. In the third column, we have a state, but we have their state abbreviation, a dash, and the name of the state, all nice and pretty. Then in columns D and E, we have a list of their favorite items that they've bought numerous times and have checked on their shopping carts as their favorite items. And then we also include the date that each of those favorite items was last purchased. So you can see that getting this into a database is going to be difficult. And we're certainly not anywhere near first normal form. You might just jump to the thought and say, oh, we've got a customer number, we'll call that our primary key. Yeah, but we have these attributes that contain multiple values, for instance, state code, state abbreviation. They're not atomic. And then we have items that contains multiple values like 22 and 33 and 99, the cat scratcher and the cable and the mouse pad. There are multiple items within one attribute. And then look at date purchased. Those dates are associated to the item and the customer, and it's just a jumble. So the first thing I want to do is go through the process of eliminate these repeating groups in D and E and copying A, B, and C a repeated number of times. So I now have changed the dynamic of the spreadsheet, dynamic of the data now, so that we no longer have these repeating groups. So the repeating group of item and the repeating group of last purchase no longer is there, and we can see that J. Reneau, me, favorite item is number 22 black mouse pad, and I last purchased it on January the 1st. I loved the 6-foot silver data cable, and I last purchased it on March the 4th. And you can see how we've now, this is looking better, but we still don't have everything atomic because the name, maybe you want to break it up into last name, first name. The state abbreviation we need to break up into state code name, and the item we need to break up into item number name. So the next thing we need to do is do our atomic structure. So we now have broken up everything into its atomic columns. So now we have everything broken up into its own column so that you can see that we have customer number, first name, last name, state, abbreviation, state name, item number, item name, and last purchased. And we've now got this to a point that we can flip the columns around, we can flip the rows around. As long as we move whole rows, we can sort it in any way. We can adjust the columns in different orders. And we've now got this kind of looking like it would be a pretty good first normal. Only thing we need to do is define a primary key, don't we? Well, we can do that just by saying, well, we could add a surrogate key, but what's the primary key? Well, what could be a good primary key of a concatenated or compound key? And I think the answer would be customer number item name, to take those two columns and to use them as our primary key. And we're now in first normal form. We're now in first normal form. Let's see what that table would look like. Okay, let's draw the entity relationship diagram shape that would represent this as a table in first normal. So we've got our entity, We've got our name. We'll call this customer favorites. We've got our customer number. We've got our item number. And those will be our primary key. So we then have customer last name, first name. We'll have our state abbreviation code, our state name. We'll then have our item name, and last purchased. Well, darn, my diagram's not big enough. That's okay. We can we can let's see, kick on the eraser real quick and just work on our diagram here. Now, if we were doing this using a nice graphics program, we would maybe make this a little prettier. But here, just for a sketch, then we'll put in last purchase date. And we can see that our primary key will be our customer number and item number. And at this point, we're in a good solid first normal. So now we've got it in first normal form. Let's look for partial dependencies. And I'm going to draw my partial dependencies on my first normal diagram using a blue line so that I can kind of try to figure out what's dependent upon what. So for instance, the last name is dependent upon the last name of a customer. Well, the last name of a customer would be dependent on the customer number and not upon the item number. It doesn't matter what item I buy, my last name is part of my customer number. So would first name, so would state code, and so would state name. So partial dependencies of last name, first name, state code, and state name are dependent upon the customer number. What's dependent upon the item number as a partial dependency? Well, um, I say that the item name is dependent upon the partially dependent upon the um, item number, but not upon the customer number because the name changes with the item number, not with the customer number. So we've identified our partial dependencies, and we can now go and create a diagram for by moving the customer information to its own table and our item number information to its own table. And we're now going to be in second normal. So let's do the diagram to move into second normal now that we've identified our partial dependencies. So we would have let's kick back over to black just so that we can see it better. So we have our customer table, which would be so it would be the customer ID, the last name, first name, state code, and state name. We would have our item table, which would be our item number, and our item description. And we know that the primary key of the item table would be item number. The primary key of the customer table would be customer number. So our customer favorites table would look like this. We'd have the customer ID as a foreign key and our item number as a foreign key and our last purchase date, which is the only attribute we didn't find a partial dependency for. Well, state name, but that's a partial dependency also. So last purchase date, and I might have changed the attribute name, but it still makes sense. So a customer can have many favorites, but a customer can exist without a favorite, and a favorite must belong to one customer. A favorite belongs to one and only one item, and an item might be on nobody's customer favorite list. So we're now in a good solid second normal. We've eliminated our partial dependencies, and we've gotten it into three tables now, of a customer table with all the customer information, an item table with all the item information, and the customer favorite table with the customer favorite information. So now let's think about or transitive dependencies. We've done our first normal, second normal. Let's see if we've got a third normal. And I think we a transitive dependency. And I think there's a dependency here because state name is dependent upon the state code, not dependent upon the customer. A customer lives in a state, yeah, but the name is dependent upon the code, and the code is dependent upon the name of the state. So I think that we need to, now that we've identified this transitive dependency, I think we need to eliminate that transitive dependency by maybe, let's do that in black so that we can keep things consistent. Maybe we'll create us a new table here called state. And I put in state code as the primary key, and then the state name as a data element, as an attribute. Let's mark that as our primary key, and I could have bolded those or hit those with a highlighter. In fact, let me hit those with a highlighter so you can see where our primary keys are. Our primary keys are just highlighted, so we can define the one-to-many relationship here between a customer has one state, but a state can have many customers. We could have zero or more customers because we could have a state that we don't have any customers for yet. Like in our little table, we didn't have any Montana customers. And we can now go in and erase this attribute because we don't need it. We can erase that transitive dependency. And let's draw our line here so we've got our line nice and pretty. And we're now in third normal form. We have no partial dependencies when we move from first to second. We have no transitive dependencies as we move from second to third, creating the state table. So now we can represent this data in a relational database. Any number of customers, any number of favorites, any number of items, any number of states, and we can model. We've got a data model now that really represents and really looks like the customer's data, and will store the customer's data in a true relational third normal way. This concludes our little first demo into database normalization, as we went through a table of customer favorites and split it out into first normal, second normal, third normal with entity relationship diagrams as we went through. Hope this now makes the data normalization a little bit easier to see. Go back and look at the data normalization text in the textbook. Also go back and watch the normalization video of the definitions of 1, 2, 3 partial and transitive dependencies, and see if we got that right. I think we did. Like this video, please follow me, please. And I hope to see you again in a future video. Thanks for watching.